https://discord.gg/flat-earth. Welcome to 24/7 Flat Earth Discord channel. Be sure to go to VC Chi Check and 1 to get your VC verification tags to get involved in the conversation about our Earth. Be sure to bring your verifiable Earth curvature evidence, though.
Enemy spotted.
Itaer Part 2.
Itaer, we got Itaer, who's another strong astrophysicist, I believe, right?
I am, in fact, an astrophysicist, yes.
Accomplished. Yes,
What
I remember
are your
you,
thoughts
right?
on
So
Neil
you
deGrasse
got a
Tyson
strong-
then?
What are my thoughts on Neil deGrasse Tyson? I don't like him very much personally.
Yeah.
That's fair. So you're an astrophysicist?
I am, yes.
And I'm sure you've heard of Miggy's 3 points before.
I certainly have.
So what do you say about the third point?
Which one was that?
How can we have the vacuum of space adjacent to our pressurized air, our pressurized atmosphere, without a container?
Well, I don't think anyone's claiming that there is a sharp divide between a pressurized environment and a vacuum environment. There is a smooth gradient between pressure and vacuum.
Okay, so what is separating the vacuum of space from that smooth gradient?
Well, where do you define the vacuum of space to be? It's not separated from the gradient at any point. It's just one end of it.
Oh, so how is our air not being completely sucked out by the vacuum of space? I don't get it.
Well, of course, you would know that the answer is that it's held down by gravity. Whether or not you believe in it, don't pretend you don't at least know that that's my answer, right? Come on.
I mean, you can take any type of gas particles in a vacuum chamber, and they still disperse in all directions. So where's the gravity in that aspect?
Well, if I took one gas that was denser than another gas and I put them in a chamber, the denser gas would settle to the bottom, right?
No.
Really? Now you can see this. It's demonstratable.
Yeah, but it's still not saying why. It's still dispersing throughout the chamber. No matter what kind of gas it is, it still goes in all directions.
But it'll do it underneath the lighter gas.
Okay, so you have the vacuum of space adjacent to the gradient, and you being an astrophysicist, could you please tell me what is the last layer, if you will, of atmosphere before you do hit the vacuum of space? What's it? Do you know what it's called? I don't know what it's called.
It's not discontinuous, right? It's just a smooth transition.
It's a smooth transition.
Using our imagination, yep, I can see that.
Yeah, it's weird.
I mean, as we all know, the vacuum of space is not a perfect vacuum, right? Sea level is not infinitely dense, but you have some density that is a gradient to some lower density space.
I think it's not more. It's not like we know. It's more like we believe. I get it.
Whatever terminology you'd like to use, you know what I'm trying to say.
Yeah, but if
so we believe.
if I'm a student,
Okay.
let's say you're a professor, right? And I'm a student.
I am not a professor, but sure.
Okay, well, you got a master's in astrophysics, so let's just say I'm a kid who's curious, which
Alright.
I am. I am curious. Where do you see an example of differentials in pressure and the smooth gradient that you're, claiming? Where else do we see that in nature? I mean, you have to have like a container for gas pressure. Like I just don't get that.
If you'd like to demonstrate it on a small scale here, a container is certainly helpful, but we see it in nature when we look at all the other planets.
Oh boy.
Yeah, that's okay.
Yeah.
All right.
Yeah.
I mean, we all know that these are the discussions, right? You guys don't bias what I say, blah, blah, blah. We've been over this, right? It's not exactly like new ground.
Yeah.
No one is
so
saying
we
anything
believe
that is
that there's
surprising
other
anyone
planets.
else, right?
Yeah,
I
we
think
believe that there's other planets, or
I do. I think I've
Hold on, wait,
seen
God
evidence.
Rocking, what'd you say? I heard you say something.
I was trying to say something.
Yeah.
I was
Go
going
ahead,
to
Rock.
say that I think they tried to explain it. I've heard it explained like this, that once it gets up there, that it's so thin that the last gradient does migrate off into the vacuum of space, but it does so at basically the same rate that all the new gas is produced at ground level. So it's sort of a system that maintains itself. The gas is produced at ground level. It migrates up, it gets thinner and thinner and thinner, and then when it gets to the top, it is migrating into space, but basically at the same rate that it is produced at the ground level. That's why it stays the way it is. I've heard it explained that way. I don't know if that's accurate. I don't know if it's true. I have heard that explanation.
Well, that brings up a good question then. You said we all know space is not a complete vacuum, right? What is it?
Partial vacuum. Some stuff there.
I know, but what does that mean? I really don't know.
Well, if a perfect vacuum there's nothing there, right? No molecules. Space is not a perfect vacuum. There are some things out there. Hydrogen nuclei mostly, particles. It's certainly quite good. It's close to a perfect vacuum, but it is not.
Close to
I
a
think they
perfect.
try
How
to
do I learn that for myself, bro? Like, how do I know that? How do I look? Is there something like, how do I teach myself that? How do I learn that?
You got to spend
That's
1,000
fair.
a year.
Some things are very challenging, if not impossible, to determine experimentally by yourself. That's true, and that does not mean necessarily that is not correct, right? Something could be very difficult to determine or understand and still be true, right? Just fundamentally, that's philosophically possible, right? It's not an argument against something being true or false just because it's hard to discover.
Well, what he's trying to say,
What?
Paul, is that we actually
Yeah, I know what he's
believe
trying
in
to
that.
say.
Yeah,
I
yeah,
know
we
what he's
believe
trying
in
to
that.
say.
I
Yeah.
believe. I used to believe in that too. Yeah, but I get it. Yeah.
And yeah, he knows what I'm going to say anyway, so it's boring.
We could go over it a little bit if you want, but yeah.
To be honest, like I want to go over it just because I want to actually hear it from someone with a master's degree in astrophysics, because it will see if there's any difference in argument. Which I've seen clips and stuff when I haven't seen really any differences, but it's one thing listening to a video, it's another thing experience it firsthand. So definitely want to pick your brain.
Yeah.
Go ahead, Godrock, and you seem like you want to say something.
I was finished. I just said what I said. That
I do have to go to bed pretty soon here, but I'm happy to stay on for a little bit longer. Yeah, talk about some stuff.
Okay.
Good.
Do you know exactly how they got the measurement of Earth spinning at 1,000 miles per hour at the equator?
Well, if you measure the radius of the Earth, however you'd like to go about doing that, know how long a day is, and there you go, right?
No, I'm saying, like, has anyone ever done that? Like, where did that number come from?
Like I said, if you know the radius and you know how long a day is, it's just geometry.
So it's 1,000 miles per hour according to nobody?
So if you know the radius and you know how long a day is, then it's just geometry.
Who measured the radius then?
Well, how about this? We're gonna apply the same math. The radius, 3959. Drop over distance to find the curvature, 8 inches per mile square. Let's take the same math and try to find the curvature.
Jesus, Stosthenes.
No, in all
Why does
honesty,
light
it's weird.
travel
Go ahead.
so far from a star? Like, do you say we can see the star and therefore and it has this luminosity, therefore we know how far away it is, or like how do you?
That's actually
if
a
you
really
find
good
star,
question. Yeah. No, that's a totally fair question. One of the hardest things to do in astronomy is to determine how far away something is. It's quite challenging. If you look at
Right. So
a
you
star
have,
and you don't know anything about it, then obviously you do not know if it's close or far, right?
right. So
Gotta
what
dig
are the
deeper.
assumptions that you like? You start with some assumptions, right?
Absolutely.
What are those?
Well, let me just ask you: are you actually asking, or do you want to chase this down to cosmic distances are all based on the radius of the Earth?
Let's
If
take
you
the
want to just
radius
go to
out,
that, we
and
could
let's
just
go
skip
with
to that
the
part and
Wait, hold on.
let's go inverse square law. Let's
Yeah, that's
Focus
what I
on the
was
inverse
thinking.
square law,
Inverse
like how
square
far the
law.
light's
Yeah.
traveling.
Okay, what about it?
Let's hit that.
Huh?
How do you find the distance of a star? What's the methodology you would use to get it?
Well, obviously it depends on the star and the situation, but the simplest way would be parallax.
Okay.
Parallax based on the movement of the Earth?
That's right. So you look at the same star 6 months apart, see how it moves compared to background of much farther away stars.
Okay, so how do you determine how far the light should travel then, using the inverse square law? Because that's what I'm more interested in. Like,
Well, the inverse square law does not
how
tell
does the
you how
light
far light should
get here?
travel. Uh-huh.
It tells you how bright it should be.
Right,
based
it
on
tells
how
you
far it is, right?
how much that light should attenuate, yeah.
Mm-hmm.
Yeah, it should
But
decrease.
the inverse square law has nothing to do with a parallax measurement. They're unrelated.
So
Okay,
what if you found out the star was too far for the light to get here? What would you say about the star?
Too far for the light to get here. What do you mean by that?
Or the parallax? Well, there has to be a max distance the starlight could travel, right? Or is it just infinite amount?
Not
It could
really,
just travel
no.
infinitely.
Yeah, go forever. The
Okay.
photon is self-propagating, so obviously, can get
Light
absorbed
goes
by
forever?
dust or scattered, but yeah, absent anything else, light goes forever, as far as we can tell.
Right. Or multiple trillions of miles of distance.
It's pretty crazy how we can see with the naked eye,
All right.
Something that's a trillion miles or more away. I don't get that.
Well,
So
Very
one
bright.
one light year is over 5 trillion miles. One
Crazy.
light year.
That's
It is
Damn.
kind of crazy. Yeah, pretty cool stuff.
Oh, okay. I do have a question. Sir. Can you explain, um, with the whole star, well, the whole, Earth position, with the sun, right? So we will be 6 months on one side of the sun, right? We would see one sky, right?
Right.
And then on like the other 6 months, we will see the other, like a different sky. But how come we see the same sky if you're on the other side of the sun?
Well, there's quite a bit of overlap.
What's the explanation for that?
Well, I mean, are you asking how you would make a parallax measurement if you're looking at different stars 6 months
No,
apart?
it's not a measurement. It's like what we see in the sky. Like, let's say, like, okay, from like 6 months we see one, whatever star up there, and then the other 6 months we would expect to see different stars. But how come we see the same star? So what's the explanation
Well, we
for
don't
that?
see the same star all years around. It's not true, right? Watch the stars for a year, they change quite dramatically over that time.
In what way?
Some stars go away and new stars come up. Then a year later, you have the same stars again.
Okay.
Well, I seen the time lapse. The stars, like, they go around and come back to the same spot. They go around and come back to the same spot.
Yeah,
So,
but that's a time lapse over one night, right?
Hey, Beasticle,
Mhm.
do you, when you go outside, you still see the same star, bro? The
Yeah.
same, whatever you were talking about, the same
Mhm.
star? Yeah, there you go. He done observations, so I'm just curious. I don't know.
Now,
I don't know shit, but
Granted, this is all naked eye observations that I've done. So, I will have to get the measurements and actually have, solid measurements every day for me to provide that argument. But anecdotally speaking, speculatively speaking, where I'm located in Las Vegas, Nevada, on my stairs in my apartments, I wanted to test this for myself in terms of just to speculate and see what the hell is going on, because I have seen time lapses of people having long exposure cameras, face towards the Polaris, the North Star, and you see perfect concentric circles with these exposure, with exposure on
I've taken those pictures myself.
Yeah, it's pretty wild. So I
Pretty
wanted
cool,
to
yeah.
test and see if that was the case for myself. So
Yeah,
every
yeah.
night
I've done it myself. Yeah, it's pretty cool.
So Okay, so but for me, every night I would sit on my stairs and I would get off work at around 9:30, 10ish. And I always noticed that the Orion's belt was right overhead. So then I made it conscious decision at 10:30 every night, basically, to look up and see if Orion's belt is in the same position for 6 months straight. Now, the reason why I did it for 6 months straight is just because, you know, it wasn't no actual reason why I did 6 months. It's just how long I looked at it until I was convinced that yeah, it's in the same spot every night. And what didn't add up for me personally is the fact that you have all these different movements that the Earth and the Sun is making, and I just didn't quite. It just doesn't make sense from what we experience, what we see. Like, how can we be spinning 1,000 miles per hour while also orbiting around the sun at 67,000 miles per hour, while the sun is also going towards the center of the galaxy, or the Milky Way, at 667,000 miles per hour? So those movements,
Well, I'm
those
not sure
parallaxes.
exactly what the question is, but there's a couple answers to that. So sort of in order, you can imagine a situation pretty easily in which case you would see like a certain star at a certain place the whole year around, right? If you're standing like, you know, near the North Pole or something, you look up, right? You would not expect that, like in the sort of globe model, right? You would not expect that star to change. So it's certainly possible for something to remain very, very static over those time periods. But also in the sort of incredulity with these large numbers, obviously the answer is that, you know, they're small compared to the distances, but also the stars in Orion, for example, right? This big number moving around the galaxy, they're going with us, right? We're going the same way. Everything's
Going with
orbiting
us?
the center of the Milky Way. Yeah. So their relative velocity is not high going around the Milky Way compared to like with us. It's not a particularly big difference. You imagine things like orbiting a whirlpool, right? If you're right next to something else, yeah, you're both moving pretty fast, but you're not, you know, departing from each other particularly quickly.
So you're saying that all these stars that we are able to see with the naked eye, some of them, which are light years away, are actually orbiting with us in the galaxy?
Essentially, every naked eye star is quite close relative to the size of the galaxy. So essentially, yes. I mean, you're not able to see things super far away with your naked eyes. It's not possible.
Yet it's perfect concentric circles around
Well,
Polaris.
the concentric circles
specifically?
are caused by the rotation of the Earth, nothing to do with any other motion.
Well, that's what I'm confused about. How come Polaris
Mhm.
is perfectly centered around the North Pole? Around, you know.
Well, it's actually not perfect, but
You get my point, though. It's like that's where the axis of spin is according to the globe model. So how does that? I just don't understand.
I'm not sure I get your point, actually. I mean, not trying to be like facetious. Like, what's the actual
you're good.
question?
You're good.
What's the actual question here?
The question is, how do we see perfect concentric circles year in, year out, with all these different movements that
because all of those movements are very small compared to the distances involved.
Okay.
I mean, which sounds a little, you know,
Convenient,
but it's true, right? Well,
sounds a little convenient.
Convenient, I suppose, is one way to look at it.
Yeah.
It's just the way things are.
The reason why it doesn't move is because the stars are so far away that we can't notice a change, yet you can still measure the distances from them. That doesn't make sense.
But that's not like an argument, right? Incredulity is not an argument. Why does that not make sense?
Because how can you be so sure of one measurement and then not be sure of a different one? I just don't understand.
What measurement are we not sure about?
So you're saying, like, you're so sure, certain about these distances that these stars are away from the planet, right?
Pretty sure, yeah.
Pretty sure, right?
Got a good number of decimal places on there at this point, yeah.
Okay, so knowing that and comparing that to what we experienced here on Earth, how do you not find the incredulity of that? I just don't understand.
I suppose that's the personal thing. If you're like, that number is too big for me, I don't buy it. Okay, fair enough. I don't really see an argument in that, right? Why is that number too big? Why do the numbers of the universe have any obligation to be like small and daily, normal for us. I don't see why that should be the case.
Well, it's just the fact that we see with the naked eye these stars that are trillions of light years away, right?
Trillions of miles. Definitely not trillions of light
Trillions
years.
of miles away, excuse me.
You only see naked eye stars, I don't know, maybe 100-ish light years, somewhere in that order. Not that far.
Okay,
Probably less.
why? Why is that the case when you have a certain amount of distance before the brightness of that star should absolutely fade away? It just doesn't make sense to me. So if you could explain,
well, again,
how
you keep saying it doesn't make sense, but I don't really understand what the question is there. If you're like, I don't believe that we would be able to see these stars if they're that far away. I mean, if you just, you could do the math if you want to convince yourself, right? If you have a certain brightness over a certain distance, then you can either see it or not, right? Obviously, if the stars are very far away, then yes, they must be very bright. Sure, all right. I don't see what's necessarily. Yeah, let's go ahead.
I mean, if you guys are done, I don't want to interrupt.
Go for it.
And I mean, this really has nothing to do with anything.
That's
But
all right.
we're in the weeds, so let's stay in it, just for the hell of it. Because what the fuck?
I like to talk about astronomy. I don't mind.
let's. So, what? How was the Earth created? The Big Bang, right?
No, the Earth is quite a bit younger than the Big Bang. So, the large cloud of gas and dust that collapsed into a protoplanetary disk, and the Earth accreted out of pebbles. There you go. That's obviously condensed version. I mean, we talk about it. I actually study protoplanetary disks in my work. So, like young solar system formation, planet formation. That's sort of my subfield. So, I can definitely talk about that at any degree of detail you prefer.
So it's the entire. It created the entire solar system.
What did?
The Big Bang.
Sorry? No,
Big Bang.
So the solar system's like 5 billion years old. Big Bang like 13. So
why? Okay, because this is my question. I don't understand why they're all moving together in unison through space.
They being
everything. The planets, the Earth, the Sun.
Well, the reason the planets and the Earth and the Sun are all moving together is because they came from the same place, which is the protosolar cloud, big cloud of gas and dust that collapses to form a solar system. So they're created, roughly at the same time they come into being. And what happens, if we want to go into detail here, is if you have a big cloud, right? Like imagine it just as like a sphere at the beginning, very big, like a parsec, and all these particles in there, gas and dust, they have thermal motion, right? They're just moving around. As this collapses due to gravity, the conservation of angular momentum will flatten it out into a disk. That's why everything orbits in the same direction, right? It's why everything spins in the same direction with the sun, most things. And you sort of get this thing naturally. We can see this happening. You can go look at, protoplanetary systems that are forming planets like right now and see these disks in various stages of evolution.
Sure.
Well, I mean, you can buy that or not. It's literally the thing that is in the sky. I mean, you can go look at it. Maybe you can't, but I mean, I have done it. Whether or not you believe me, I guess it's up to you. But I mean, I've seen them myself, so I can post a picture if you want.
You wouldn't be able to see them. You wouldn't be able to see them move. You would see no parallax because you don't see any parallax in stars. You wouldn't actually be seeing this happen, right? You just like okay, if you took a point in what's happening today and then a point and then looked at it again a year from now, how much difference would you see?
Not much. I mean, obviously the time scale here is quite long. What you do is you look at a region, generally like Taurus or Ophiuchus, that's forming stars and planets actively, and you look at the different objects there, and they will be at sort of various stages in their evolution. I mean, this is what we're constrained to do because the universe is slow and humans don't live very long. The time scale to form a planetary system out of a cloud is on the order of 10 million years. So yeah, you don't see much change from time to time. So what we're restricted to doing is just... Sorry?
Sorry, I didn't mean to cut you off. I just want to know, like, what's the telescope? What's the tool you use to see this?
I've used a variety of different telescopes. If you want to look at young star-forming planetary systems, ALMA is generally the best bet. That's ALMA, ALMA. I've used that before. It's a millimeter wave interferometer in Chile.
If only we could live for 10 million years, huh?
That'd be pretty nice for a wide variety of reasons. Yeah.
If we entered a black hole, would we be like? How much time would pass? How much time dilation?
The equations say it would sort of
Can you calculate
trend to
that?
infinity, but I don't know. I mean, obviously, you've never done it. Just math. That's not really my subfield.
So we,
Relativity and stuff. I study
we just got to
young
do that.
stars and planets, right? So.
Yep.
You know, I
Appreciate it.
used to be completely obsessed with space. Not to the extent, never got to the extent that you have, but
Science
I hear that a
fiction is
lot
fun,
from people
bro.
in here. I hear that a lot from you guys. Yeah, it's interesting.
well,
Space and dinosaurs, man. That was my room growing up. Space
for
and
real,
dinosaurs.
man. Well,
Well, if it isn't the person who takes photos of exoplanets.
Me, what's up, man?
Timbo.
To be fair,
Busted.
Nah, I'm not gonna harass you, mate.
Bust your fantasy balls. Don't worry.
Have you
I'm like spamming in the chat right now.
oh, I'm sorry, I'm in the kitchen. I don't bother
be.
reading the live stream chat. It's usually a bit of a mess. Just making.
Been
I
a
think
while.
you would quite enjoy my messages, Itaer.
Well, what do you? While I'm making this sandwich, you can tell me what you want to talk about.
I just want to hear all the crap that you're gonna say.
Busted.
And
I'm in
then
the chat.
tell us that. Oh, but it's all assumptions.
You want me to read what I wrote in the chat?
If you'd like to read your in the chat, go ahead.
Yeah, because it's funny. Oh, if you use the inverse square law, just up the brightness of the star in the sky to cancel it out. Not a problem that it would logically mean that the whole vacuum of space should all be lit the heck up.
There's a name for that. Actually, it's called Olber's paradox.
Oh, I know. Oh, yeah, okay.
it
Don't worry
called?
about the.
Oh, sorry, Flatsy. Go ahead.
I'm not done. You got to hear my spamming, okay? Then you can talk. Don't worry about the second law of thermodynamics. Don't worry about Newton's laws of motion. That would mean Earth is the inertial reference frame by necessity. And then I said he looks at 1 to 7 pixels.
Well, I believe the picture I sent was like 3 pixels on his side, so that's actually 9 total pixels. Yeah, just if someone's counting.
Oh, okay. I should put 1 to 9 pixels then.
Thank you, please. I appreciate the accuracy.
You got it.
Yeah, appreciate that.
Just for clarity, Itaer,
Yeah,
can you explain to the guys how you know that there's an exoplanet floating around a star? Just go through the process.
Let's talk about exoplanets. Yeah.
So you've got a light. Like let's call this the star in the sky a light, and then that light dims by a certain percentage.
Yeah.
And then you say because that light dims by a certain percentage, that means we have a planet.
Not quite. You had me till that last part. Really, what's going on here is we say, if that light dimming is caused by a planet orbiting around it, then I might expect to see some other things. And then I go look for those other things, and if I see them, I say, hey, it's probably a planet. And if I don't, which sometimes you don't, you say, I might be due to something else. And you have some other things.
Specific. Let's get
hyper-specific. There's actually almost more common than... Sorry, go ahead.
Wait.
Yeah, go ahead.
Is it a light? Is it a light in the conventional sense?
I have no idea what that means.
So how are we seeing this light?
By detecting photons? I'm not really sure what you're getting at here. Sorry.
What's being used to view it?
Telescope? Or are you talking about the detector, which is generally a CCD?
Right. Yeah. What sort of lens are we looking in? Sort of what spectrum?
I mean, you could look at them in whatever spectrum you'd prefer. Obviously, exoplanets are normally detected with optical photometry.
And in this case, what are you doing? Are you seeing
Mine's optical,
through? It's optical. Okay.
Yeah.
Cool.
So I think it's like 600 microns, or nanometers, excuse me, 6 microns, roughly.
Do you think it could be anything else do you think it could be something else that...
Yeah, it's totally possible. That's why you have to ask sort of more follow-up questions, right? You say, okay, well, if it's an exoplanet, it should do these things. If not, it should do these other things, right? And you asked me, like, what else could be a great example of something called an eclipsing binary, where you have one star orbiting another star. And that has, detectable differences than just an exoplanet.
Well, you'd see two stars. That wouldn't be a difference.
No, not necessarily, right?
Though,
These things are very far away. They are not resolvable.
Okay,
Can't
so
detect the difference.
you now you're saying.
So
So
it's
how do
not
you
optical.
detect that two stars are rotating around each other then?
Right, yeah, if it's not optical. That's what I was
say it's
asking.
not optical. This can be detected with optical wavelengths. So if you have an exoplanet orbiting
You
a
said you
star,
can't
right?
see it.
I said it
You can't
wasn't
see it.
resolvable, which means you can't distinguish between the two stars.
Oh.
Yeah,
So they might
irresolvable means can't see it. Yeah.
you cannot distinguish between the two stars.
So how do you know it's two stars?
Well, you don't know. You can get evidence. And so if you have two stars, then you would expect certain features in the light curve. Specifically, you would expect
But
when one star is passing in front of another.
Expect it compared to what though? Because you've got no baseline.
Well, I mean, you can do the math, right? And say, okay, if I have a big star, right, and there's another star orbiting it, what would the light from those two things look like if they were orbiting each other? And it gives you some testable things, right? Okay, well, if
And
it's
then
an
how do you
eclipsing
confirm
binary,
it in
What would
reality?
it look like if it was just one big star?
they wouldn't be
Yeah.
variable, right? It wouldn't be variable. Not on this
Why
level.
not? How do you know that?
This is not proof, right? It's
Hey,
evidence.
gentlemen, can I press pause on the conversation real quick? I just want
Yeah,
to
go
address
for it,
somebody
man.
in the room and ask them if they want to come down to chill and have a conversation because you guys are going at it. It's Veg time, BC verified, but no roles. If you want to have a conversation, I'll go down to chill with you and we can talk. Or if you just want to listen, that's fine.
I think he wants to
All right.
listen in
I'm just
here. Actually,
Okay.
we've been talking in the lobby. Or I mean, if that's fine too. If you wanted to go down there, that's fine
jump
too.
in here as well if you want.
Honestly, this is very interesting conversation because I like to. I find it funny that it's unresolvable. Just so you don't really know. You just have to make assumptions about these exoplanets, and then you see the picture of these exoplanets. How the hell did they get those details like that? Like how? What is that? All assumptions there?
Photoshop.
I mean,
Aren't most stars claimed to be binary systems?
Most systems are binary. Most stars, like statistically, are not. So, if you have two stars orbiting each other, right? It's binary. Most systems are binary, but you got enough stars that aren't binary that it works out that I don't know. That's just semantics.
Wait,
Yes, there's a lot of binaries out there.
orbiting each other. Wait. Clarify that for us. Orbiting each other.
Yeah, that's right.
So how do they orbit each other?
What is so confusing about that?
Well, how could possibly, like, okay, so in the heliocentric model, right, Earth's orbiting the sun. Let's say in another system, the Earth was orbiting the sun and the sun was orbiting the Earth at the same time. How does that work?
So if two objects are comparable in mass, one does not orbit the other. They orbit a common center of mass called the barycenter. And this is actually true even in the Earth-Sun system, but if you work out the math, the barycenter is inside the sun, so we appear to orbit the sun. But if the Earth was much, much larger, comparable to the size of the sun, you would see us orbiting our common center of mass.
what would be the common center of mass?
It would be, you can imagine that you took a stick, right, and you put the sun on one end and the other sun on the other end. The center of mass is where that would like balance if you held it on your finger.
So where's the moon? Is the moon orbit within the Earth, or is it
the barycenter of the Earth system is also within the Earth? Yes.
Yeah, but how do you know the Earth is moving?
Wow.
The first movement in this chain of movements would have to be the axial rotation of the Earth, right?
Hi, Heretic. How's it going,
coming
man?
in hot?
That's not an answer.
Well, we've been over this like so many times, right?
I never heard this.
I heard it earlier. Nobody gave an answer as to how the axial rotation was measured. They just said it was calculated from the assumption of the radius. But still, even then, that would be begging the question, because how do you know it's not a geocentric stationary sphere? That you're begging the question of as well.
That's a good question.
Begging the question. Yeah.
Yeah.
Well, that's all you're doing, then we're just talking sci-fi, so you guys can carry on doing that if you want. Unless there's some measurement of rotation of the Earth.
Yeah, I brought up the fact that we would be, Newton's laws of motion. We would be the inertial reference frame by necessity in what you're viewing. That's a problem. Also, there was another thing I wanted to say. All the stars that you claim to, go and look at, 1 to 9 pixels. Sorry about the 7 earlier, but whatever. You know, uh,
I'm just
you,
giving you a hard time, Flatsy. I'm sorry.
I know it's fine. It's fine.
The Earth would be non-inertial if it's rotating. It's treated as inertial though, so practically it's stationary. So where's the evidence it's not?
Exactly. Exactly.
Good point.
And I want to know, don't you find it a bit odd that all the stars that you look at are, even the ones in retrograde, are all relative to Polaris, not the sun?
What do you mean by relative to Polaris?
They all are in respect to Polaris.
Sorry, I'm still not following you. In respect to? I don't really know what that means.
They move in respect to Polaris being the center.
You're talking about like if you take a long exposure overnight or something. Well,
Yeah,
Polaris is not exactly
even
on
in
that.
retrograde over time, if you study the stars over time, they're all moving in respect to Polaris, not the sun.
I'm not sure exactly what you're saying, but I'm pretty sure that's not true. I mean, the stars all have some small motion and proper motion you can detect, and it's essentially stochastic. So
Prove it.
all right.
Well, are you Flatsy? I'm just trying to clarify that question because, like, so you're saying even if Polaris it might like minutely moves over the course of time, everything else around it moves in
Yeah,
relatively too.
even the stars that are claimed to be planets that move in retrograde still all move in respect to Polaris's position.
Yeah,
and even if Polaris slightly moves, it doesn't matter. They're all still in respect to Polaris in the position.
That also begs another question. Is there any major telescopes that are on the southern hemisphere?
Certainly, the one I talked about earlier, ALMA, that I've used.
ALMA.
That's in Chile.
Okay.
And did I say retrospect
the
or
EU has
retrograde?
a,
I meant to say
You said
retrograde.
retrograde. You said retrograde.
VLT's down there. Quite a few telescopes in Chile, actually.
Did you say used, so physically used, or logged onto by a computer?
Both, actually.
Oh, it's remote?
Yeah, mostly it's remote. Most observing is remote these days.
It's
Because,
convenient.
no one wants to go to the top of the fuck off tall mountains, right? It's a pain in the ass. I've done it.
Yeah, who wants to
Kinda
do that?
sucks.
Just look at a video screen, right?
Listen, it's very nice at the top. It's beautiful, but it takes a long time. And go to
done it?
one in... Yeah, I have several times.
Have you noticed any
He's
difference
never done it.
remote?
Listen, if you don't believe me, I mean, these conversations have to have a certain level of good faith, right? If you don't believe that I'm telling the truth about basic shit like that, I don't really know what to tell you, man. Like, it's my job. It's what I do.
Did you notice any
You sound like a
difference-
priest, bro.
But did you notice any difference between you physically going to where the telescope is versus you using it remotely?
Differences in terms of, like, what?
What you're seeing.
Well, I'm looking at different things every time, so...
Okay.
I mean, most times at least, yeah. Going up to the telescope's kind of a special occasion just because it's, it's such a pain to get up there.
I
I mean,
just
when I went
want
to Alma, I had to
to
fly down to
reiterate.
Chile, right?
I just want to reiterate that your whole work is based on assumptions, correct?
That's one way to look at it, yeah.
And do you consider what you do science?
I do, Flatsy, yes. I mean, we've been through this so many times, right?
Okay, so what is the observed phenomenon?
Yeah, you hit me with independent, blah, 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 right?
Yeah, exactly, because that means it's pseudoscience.
Yeah,
by the way.
hold on.
So?
I'm confused. How can assumptions be science? If everything is based on assumptions, where's the science at?
I don't believe that everything is based on assumptions, but at a certain point, it's a matter of opinion.
Well, so far you haven't given any evidence. It's all just been assumptions, really.
Well, I mean, from my point of view, right? If someone says, hey, this might be the way things are. If that's the way things are, we expect to see this thing, and we go look and we see that thing. It's not proof, but it's evidence, right? And you do that a bunch of times, you really start to say, okay, we got a lot of evidence to support this. It's not proof, right? But if you got all this evidence, okay, maybe you believe it. Maybe you don't. Everyone's standard of evidence where they decide if they believe something or not is personal.
So you're saying that looking at something is evidence?
Can be for me, yeah. Looking in a scientific way, right? Asking a question, saying, okay, well, if this is the way it is, then maybe I expect to see this, and you go look
Yeah,
and
but
you see that.
why
right?
would you? But why would you ever start anything with if?
It's basic of science, man. If this, then that.
Is it?
Sure.
I mean, so let's take boiling water. Where does the if come in?
In what sense?
Well, so we're going to apply science to boiling water. Tell me the if.
Okay. If I apply heat to this water, it will come to a boil.
Okay. So then we can test it and then we can prove it, correct?
Yeah, listen, I get the whole thing
Okay.
between
Okay. All
observational and
right.
experimental science, right?
So see, you're already starting to run away,
I'm not running away from anything.
right?
Just had this
Yeah, because
conversation several times, right?
you're realizing where the conversation is going to go. It's going to go to a place where you no longer have any answers because none of it is true. Because when you start with an if and then you can't come to a conclusion, it's bupkis. So if the pink shit on the ground came from a unicorn, we should be able to prove that. So when you make statements, if we see this, then this, where's the proof?
Science is not in the business of proving things. It is
Oh, it's
gathering
not.
evidence to favor or disfavor ideas.
Favor or disfavor? What the fuck does that mean? What?
You have a hypothesis, gather evidence. That evidence either supports or does not support your hypothesis.
So basically, yeah, you just live in a world of assumptions. You don't live in reality.
I understand that is your position.
So no, that's your position. You have to accept that. Because you don't live in a world where evidence or proving things is necessary. It's all
Evidence
in
is
your head.
absolutely necessary.
It is. Okay, so where is any evidence for anything that you've been saying?
Well, talked about it at length, right?
Is evidence.
Wait, well, what's evidence?
Proof.
I have
The
no idea what that
definition
means.
of proof is evidence. Look it up. Look up the definition of proof and read it to us.
Or synonyms. That'll work.
I'm going to head to bed, guys. I bet it has been lovely as always.
Okay.
Nothing
You do this every
rooted
time,
in
right? I come on and I say, I'm
assumption.
going to hang out for a little bit. I got to go to bed. And I go to bed. Everyone's like, it's going to bed. Look at that. I'm like, well, listen, man. Got to get some sleep,
Hey,
I can stay here
hey,
for
you-
8 hours, and if I left, people
hey,
like, oh,
you
look at
still
that. Here he
didn't answer
goes.
my question. You still didn't answer my question earlier.
It's a lot of questions, man.
No, remember when you mentioned about the we know the radius, so we use the radius and to figure out the how fast the Earth spin,
Yeah.
right? 1,000 miles per hour. Well, I said, well, if you applied that logic, so let's use the radius to measure the curvature of the Earth, 8 inches per mile square, drop over distance. Can we do that? Can you do that?
Nope, never done it. I don't know.
Okay.
I mean,
Alright.
that's just such
So
a tired
so
subject,
so it's
man.
all imagination. I get it. Okay, I got it, bro.
He wants to
But-
go to bed.
Yeah, that's
You have a
fine.
good
That's
night,
the
guys.
you
I'm going
too.
to bed.
The whole radius of the Earth is the first rung of all of the cosmology. So
Yeah,
if
we
it's
covered
wrong,
that earlier.
yeah, if it's wrong, then it's all wrong because the next rung would be that Venus is the same size or relatively the same size as Earth, and that's how you decide the whole
where?
orbital system around the sun.
Yeah, we had a
how
whole
big the
conversation about
sun
this. We
is,
talked about the
how far away the sun is.
fusion,
Yeah,
right?
but these are all
Spectra, black body
assumptions.
curves.
Yeah, but these are all
how
assumptions.
can you make a whole cosmology out of assumptions?
That's right. Exactly. This is a problem.
At a certain point, like all this aside, right? It does come, if nothing else, if all this is false, and we didn't measure the radius, blah 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 blah, there are a remarkable number of coincidences. Things that we would expect to see that we look out there and see. It's
Oh,
absolutely possible they were put there to
so
fool
you
us.
mean that they've been seen for, thousands of years, and we have recorded history of people tracking these things, so it's not actually prediction.
No, I'm not talking about any of that. I'm talking about things like
You don't think that that's
the
you don't think-
radioactive nickel line in supernova spectra. Crazy shit
What?
that would never have predicted.
What?
Right? These things are predicted long before they are observed.
Nobody, no.
Are you a coincidence theorist?
I'm not saying it's proof. I'm just saying at a certain point it starts to get a little bit incredulous. But anyway, guys, like I said, gotta go to bed. Been a
It was
pleasure.
a good laugh. Thank you for that last
I'll
little
talk to
bit
you
of
later.
laugh.
Have a good night.
Later, hater.
Woo!
What is your profession?
See, old friend, I brought more soldiers than you did.